Welcome, folks, to second lesson of magnetic effect of electric current. The previous lesson we looked at magnetic field, that is the effect when current flows in a straight conductor. Today we are going to look at what is the effect when current flows in a solenoid. The effect is the same, magnetic field. But how can we draw, how can we ascertain that there is magnetic field when current flows in a solenoid? What is a solenoid? A solenoid is just a long wire wound round in a cylindrical form. An example is here. Okay, so you have these are coils, these are turns. Okay, these are turns. It is going round, it is going round, it is going round. So this now coil is having a better name, solenoid. If you say a coil, you're okay, but there are many coils. So these are solenoid. It's good to distinguish. This is physics. This is where we get engineers, doctors. So we don't want you to do funny thing when you're a doctor or you're an engineer or when you're a teacher. Solenoid. Okay, this is just an example. Solenoid. Now, let us go to the diagram. This is a setup which you can use to verify. So you have a wire that has gone round, it has come, gone in. So you can see coming up a dot. Coming towards you is a dot. Going inside, away from you. Okay? So it has come up is a dot. Then this wire has gone in. It is going away from your eyes. X. Tail of an arrow. Again, it has come up, a dot. It has gone in. Tail of an arrow, X. Very important for you to know those symbols. So, how do we ascertain? Number one, you can sprinkle iron filings, okay, when the switch is on. Maybe we start it this way. Switch on the circuit. So when we switch on the circuit, what happens next? Current flows. The size, the magnitude of current can be varied using variable resistor. Allow me to use VR now, okay? Just for explanation and for understanding. Variable resistor is used to vary the amount of current in a circuit. So as the current flows, sprinkle the iron filings. So number one, we will observe the iron filings taking a particular pattern. Okay? So up to that moment, we have to account for that pattern. Number two, don't use iron filings. Use a plotting compass. So you place it somewhere, a plotting compass, it has a pointer. Put a dot at the tail and at the head. Okay? Then remove it. When you remove it, put it on any of the dots you want. So suppose I put it up here. You will find again it is pointing in a particular direction. Put the dot there. Transfer the compass. Each time drawing the way the arrow appeared, the pointer. So you do this, it will lead you itself. You can't force. that will give you the direction of the line of force. So this is the direction you will get from plotting compass. Note the middle of the dot and X, it will be uniform. The lines there will be parallel. So parallel lines means uniform field. Let us remind ourselves magnetism. When lines are close together, when the line density is high, strong field. When they are separated far apart, weak magnetic field. Close together, strong magnetic field. Parallel, evenly spaced, uniform magnetic field. Okay? So, using ion filings, patterns, we can observe only patterns, but we can't tell the direction. Direction can be given by two methods. One, plotting compass. Two, if you remember magnetism, this side, you look at one side at a time, please. Face one side at a time. So, I am facing this side. If I face this side, then this current is moving in anti-clockwise direction. So you put anti-N like that. This is the way the current is coming up, going in. So this is like north pole. So this behaves like north. Now this is south. So lines of force come from north to south. Folks, three things I've talked about. One, sprinkle ion filings, you will get patterns. No direction. Number two, use plotting compass. It gives you direction. Number three, without plotting compass, you analyze the windings from one side at a time. So if I analyze the way current flows from my right hand side, it flows in anti-clockwise direction. So anti-north. This is north pole. Automatically, if you are correct, this is south pole. You don't need to do two sides. Pick the side that is easier for you. If I wanted this side, then I look at it from that. Okay? Now, this experimental diagram can be put in symbolic diagram. So remember, the dot coming to you, X away from you. So you can analyze and get the fields. In conclusion, we come here. How can we change the strength of magnetic field? Okay, how can we change? So can we concentrate down here a bit? I think we can. I've put my camera now down here. Yes, I want us to concentrate here. So if I ask you, state the factors affecting the strength of magnetic field. State the factors. Please don't just name them. Tell us this factor and its consequence on the field. Increasing turns increases strength. Let us go down. Can I focus here? These ones are roughly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 turns. On average, we have 11 turns here. Okay? We have 11 turns. You will get example. These are 11 turns. Suppose I had a second scenario, I have 20 turns. Okay? Turns, okay? Winding coil. Don't say turns as a measure of mass. So these turns are 11. The other one is 20. What I'm saying, 20 turns, when current flows through that solenoid, you will get a stronger magnetic field compared to when we used only 11 turns. Very good. Number 2, increasing current. When you increase current using variable resistor, what does it mean? When you reduce resistance, we have more current. So when there is more current, you get also a stronger magnetic field. 3, winding the coil on a soft core. This is a soft core, the red biro. Okay, so when you have a soft core, this one has no soft core. Okay, this one is just a solenoid. Okay, we focus up so that we get it right here. This is a solenoid, an example of a solenoid. Now I put a core. Okay, and this core normally is a soft iron. Do you remember? A soft iron versus steel. What are the characteristics? A soft iron acquires and loses magnetism very fast. So when you use a soft core, it concentrates the magnetic field, and therefore you have a stronger magnetic field. I hope you have enjoyed. Bye bye.